Alright, here's another example for finding a limit of a rational type of function. And so what we're going to do here is we're going to look at x squared, the limit of x squared plus x plus 2 divided by x plus 1 as x approaches 1. So here we have a function. This is really two functions. We have a f of x function in the numerator, and then in the denominator we have another function we can call g of x. And what the theorem in your textbook says is that the way you find a limit when you have two functions divided by each other, or a ratio, is you find the limit of the numerator and the limit of the denominator and you divide them. So first we're going to find the limit of the numerator. Since x equals 1, when x equals 1, this function is defined. So we have 1 squared plus 1 plus 2. In the numerator we get 4. And in the denominator, this is also one we can directly evaluate. When we put in a positive 1, we have 1 plus 1 equals 2. So limit in the denominator is 2. 4 divided by 2 gives us 2. And that would be the limit for this function. Another type of limit property is when we have composite functions. So you can see here if we have the limit of f of g of x, so we're composing a g of x function which has a limit L, and then f of x, we're going to compose with that. We have f of L. So f of g of x, we take f of the limit of g of x as x approaches c, and we're going to get f of L. Here's an example of that one. Okay, so we have two functions, and the first one is the limit of x squared plus 4 as x approaches 0. And you guys can see that, again, this is one that is defined at this spot, and so we're going to substitute a 0 in for x, and we're going to get 0 squared plus 4, or 4. Okay? And then if I want to take the limit of the square root of x as x approaches 4, I could take the limit, or I would just put, again, directly substitute a 4 in for x, and we get the square root of 4, which equals 2. So it follows then that if we take the limit of the square root of, the limit as x approaches 0 of the square root of x squared plus 4, that would be, again, the limit here. If I plug in a 0, you get 0 squared plus 4, and we take the square root of that, which is also 2. So what you have here is really two functions. You have the square root of x squared plus the square root of 4. Here's one more example of this. So we have two functions again, because the limit as x approaches 3 of this function, so limit of 2x squared minus 10 as x approaches 3 again is defined. We simply substitute a 3 in for x, and we get 2 times 3 squared minus 10 equals 8. So limit of that function as x approaches 3 is 8. And the limit of x cubed here, when x is 8, so you're seeing we're taking this 8 and transferring it into there is kind of what we're doing. So it's composing functions, but using the idea of a limit to do it. So we're going to substitute the 8. The cubed root of 8 is 2. So it follows then that the cubed root of this first function that we were talking about as x approaches 3. So again, you can see we'd substitute a 3 in, and we'd evaluate it, and then we would take the cubed root. So underneath, again, you'd get 9 times 2, you'd get 18 here. 18 minus 10 would give us 8. Cubed root of 8 is 2. So really taking a function and another function, and we're composing them together. And finally, in this section, there are the limits of the 6 different trig functions that we're going to talk about the limit. The limit of sine of x as x approaches c is the sine of c. So you're going to see a lot of direct substitution again. We're substituting that c value in. The limit of the cosine of x as x approaches c is the cosine of c. The limit of the tangent of x as x approaches c is tangent of c, and so on. You can see with cotangent, cosecant, and secant, we have the same thing for all 6 of those. Alright, so here's 3 examples of that. limit of the tangent of x as x approaches 0. We directly substitute a 0 in. The tangent of 0 is 0, and so the solution to that limit is 0. The limit of x times the cosine of x. So here we have kind of two functions, right? We have x and the cosine of x as x approaches pi. So we're going to break these apart and take the limits separately. So we have limit of x as x approaches pi. That's going to give us a pi. So that's from this limit. And the second one, the limit of the cosine of x as x approaches pi, is the cosine of pi. So this gives us this second part here. And so pi is by a number. Cosine of pi is -1. That's our x coordinate at pi radians on the unit circle. -1 times pi gives me -pi. One more. We have the limit of the sine squared x as x approaches 0. So again, you can see we can rewrite sine squared x as sine of x squared, directly substitute a 0 in, and we have the sine of 0 squared, the sine of 0 equals 0. And so we get 0 squared equals 0.